All right, you guys, let's continue our discussion on solving trigonometric equations and inequalities. Let's look at this second example. So it says solve for sine x cosine x equals square root of 3 over the interval from 0 to 2 pi. Okay, so just like before, we want to see how many trig functions are included in our equation. We want to also see if our equation is linear or quadratic, so that way we know how to approach it. So the first thing I'm going to do, I'm going to write out our problem. Oops. Okay, so based on our problem, the way that it's written, we see that we have two trig functions. Okay, so our steps before always wanted us to see if we could separate them legally. Before, we could separate our trig functions using something like factoring, where we could split them apart. However, in this case, we're not going to be able to do that. So our best bet is to see, can we make a substitution in such a way that we will only have one trig function left after the substitution is made. Okay, so let's see if we can find an identity that resembles what we're looking for. All right, so if you guys look here, let's change the color. This identity here is the double angle for sine. Okay, so it says if you have 2 sine A cosine A, you could replace it with the double angle for sine. Okay, so that may prove to be helpful for us. Okay, so let's go back here. All right, so that identity said sine 2 theta is equal to 2 sine theta cosine theta. Okay, so let's see what we can do with that. So currently in our problem, we have 4 sine x cosine x. So right now, this kind of looks like the identity, okay? The only thing that's different is that there's a 4 coefficient in front of ours, but there's a 2 in the identity. So what we could do, we could factor out a 2, which would leave behind 2 sine x cosine x equals the square root of 3. Okay, so anytime you're making a substitution, you can only substitute back in what you have. You have to make an equal exchange. So what's in the parentheses now is now equivalent to the double angle for sine. So I can make that substitution. So this is equivalent to sine 2x, and that 2 from the outside is going to remain, equals square root of 3. Okay, so now that you see that we've made that substitution, do you see that we only have one trig function now? Okay, so that's our goal. So if we can't separate our trig functions legally by factoring or something like that, then we will try to separate them or create in a situation where we only have one by using an identity. Okay, so I'm going to go ahead and solve for x. So the idea is to get x by itself, to isolate it. So I'm going to divide both sides by 2. So I have sine 2x equals the square root of 3 over 2. Okay. Now, in order to get x out of that trig function, we're going to have to use the inverse. So 2x equals sine inverse square root of 3 over 2. Okay. Now, because this argument here, all right, is 2x, this is where this problem is going to differ a little bit than the ones that we've done before. All right, so kind of stay with me because we're going to do a little janky things in a minute. All right, so let's solve this part here. Okay, so this is the thing that we've always done. We're looking for an angle that has a sine value of square root of 3 over 2. Because we are looking for sine, we are looking for the y value. All right, so let's go over to our unit circle, see if we can find those values. All right, so if we're looking for angles that have a sine value of square root of 3 over 2, so let's write that. So right now we have 2x equals sine inverse square root of 3 over 2. So right now we're looking for this part. We're looking for angles or thetas that will give us that, okay? So let's do this. All right, so if we're looking for the sine, we're looking for angles that have a y value of that. So that's pi over 3 is one. And the other one is 2 pi over 3, okay? So our original instructions told us, they gave us this interval from 0 to 2 pi, okay? Let's write that a little better. All right. Now, anytime they give you these intervals, okay, I want you to think about it like this. This interval that they give you is always where x is. Okay, it's always where x is bound. That's your domain, okay? Now, for this problem, not only are we concerned with x, we're concerned with 2x, okay? So it's like we doubled x. So we also have to double where x is bound, okay? So it's the same thing as multiplying this interval by 2, okay? So we're doubling our interval because we're dealing with a double angle. So if you multiply 0 by 2, that's 0, okay? But 2 pi times 2 is 4 pi. Okay, so now we can find answers anywhere from 0 to 4 pi, which means that we're traveling around the unit circle twice. Okay, so the first answers that we got was pi over 3 and 2 pi over 3. They were the answers that existed between 0 and 2 pi. So let's write those here. Pi over 3 and 2 pi over 3. Okay, now we need to find the ones that exist when we go around the unit circle again. All right, so if we were to travel around the unit circle a second time, we would still come back to the same point that would have the same sine value, and we would come back to this one again. So we were just finding their coterminals, and we know coterminal angles differ by 360 degrees. So it's like we take the two original angles that we had and we add 2 pi to them. Okay, so let's do that. So for the other two, the ones that are down here, it's like we take pi over 3, which is our first answer, and we add 2 pi to it. Okay, and that's going to give us 7 pi over 3. And it's like we take the second answer we had, 2 pi over 3, and we add 2 pi to it. And that's going to give us 8 pi over 3. Okay, so in total, there's 4 answers that we get when we travel around the unit circle twice, which gives us our interval from 0 to 4 pi. Okay, so follow me because we're not done yet. All right, so right now we had this. We had 2x equals sine inverse of square root of 3 over 2. Okay, so the right-hand side of our equation produced 4 answers for us. Pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. Okay, and those are equal to 2x. All right, now we have to solve for x. So x is being multiplied by 2 on the left-hand side. So to get x by itself, we're going to divide both sides by 2. Okay, so that means x is going to equal each of these angles divided by 2. So anytime you're dividing by 2, it's the same thing as multiplying by a half. So if you need to see that over here, it would be like pi over 3 times a half, which would be pi over 6. It'd be 2 pi over 3 times a half. The 2's would cancel, which would give you pi over 3. It would be like 7 pi over 3 times a half, which is 7 pi over 6. And 8 pi over 3 times a half. This would reduce to 4, which would be 4 pi over 3. So those are my 4 answers. So pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. Okay? Those are your 4. So when you're doing these trig equations and inequalities, if you get to this part here, the same part we got to, where you have a value over here that's x is being multiplied by, remember that you have to multiply your interval by that same coefficient, and then you're going to have to divide your answers that you get from the unit circle by that coefficient. All right, so if you need to see this one again, rewind the video. I know that that's a lot. We'll see another example in our next one.